Hello friends, today's question. A small block is connected to one end of massless spring of unstretched length 4.9 meter. The other end of the spring, see the figure, is fixed. The system lies on a horizontal frictionless surface. The block is stretched by 0.2 meter and released from rest at t is equal to 0. It then executes SHM with angular frequency omega pi by 3 radian per second. Simultaneously at t is equal to 0, a small pebble is projected with a speed v from point P at an angle of 45 degree as shown in figure. The point P is at a horizontal distance of 10 meter from O. If the pebble hits the block at t is equal to 1 second, find the value of v. So this is a block and this is the pebble. Total distance between the, you can say, where this block is connected to the pebble is 10 meter, and this block is stretched to a distance of 0.2 meter and then it is released, because of which it executes an SHM, and this is at t is equal to 0. So at same time at t is equal to 0, this pebble is projected at a angle of 45 degree with the velocity of v, and we have to find out if the pebble hits the block after t is equal to 1 second, what will be the value of v. Okay, so this is a combination of the projectile motion as well as the SHM. Okay. So we are going to start with the SHM and then we are going to shift to the projectile motion. So we know that the block is in SHM motion, so we can write the block SHM motion and we know that the equation for the displacement of the block, which is in SHM, is given as x is equal to a cos omega t. Okay, so you can write that the equation for displacement of a block in SHM, it is given as x of t, x naught, and cos of omega t, where this x naught is the maximum amplitude, x naught is our amplitude. In some of the formula this is also given as a, and omega is the angular frequency. And in the question it is given that the block is stretched to 0.2 meter and released from rest. So it means the value of x naught is equal to 0.2. You can say x naught is equal to 0.2 meters, and this is at t is equal to 0. So let's find out what will be the displacement at time t is equal to 1 second. So you can say at t is equal to 1 second, we get x of 1 will be equal to 0.2, and we have cos of angular frequency is given as pi by 3. So this is pi by 3 multiplied by 1. So we get this, the displacement after 1 second is our 0.1 meters. So from here we can say that the block is at a distance of 0.1 meter from the equilibrium position after time t is equal to 1 second. So after 1 second, the block is displaced by 0.1 meter from the equilibrium position. From the equilibrium position. Now we are going to find out how much will be the horizontal distance traveled by the block. So next is horizontal distance traveled by the block. Horizontal distance traveled by the block. So in the question itself, it is given that the block starts at 0.2 meter from the equilibrium position. The block starts at 0.2 meter from equilibrium position. Equilibrium position, and after t is equal to 1 second, it has moved by 0.1 meter, sorry, and after 1 second the block has moved by 0.1 meters. So therefore we can say that the new position of the block from the point O, new position of the block from point O will be equal to 4.9 plus 0.1, and that is equal to 5 meters. And point O is the point where the spring is fixed. So let us try to understand. We are given by using a simple, you can say, diagram. It is given to us that our block in the unstretched position, so this is suppose unstretched position of the block, and under unstretched condition this will be our position of the equilibrium, that at x equal to 0, and this is given as 4.9 meters. Then the block is stretched such that from the position of the equilibrium it is displaced by the 0.2 meter. Okay, so now it is at a position of displacement, and this is our, you can say, x naught or a, or we can, this is x naught and this is given as 0.2 meter. So this displacement will be our 0.2 meters, okay, from the equilibrium position, and this part will be still our 0.9 meters. Now from here it is released at t is equal to 0. So this is the position at t is equal to 0. Now we are going to find out how much distance it has been traveled in t is equal to 1 second, and t is equal to 1 second it has traveled a distance of 0.1 meter. So therefore now the block will be somewhere here, and this is still our 4.9 meter, and from the equilibrium position this will be 0.1 meter, and this is at t is equal to 1 second. Okay. So total distance from this is our point O. From point O, this total distance is our 5 meters. So this is the basic. We found out at what position is the block after t is equal to 1 second. Okay. So from here we can say that the block will be at a distance of 5 meters from point O after time t is equal to 1 second. Okay. Now we are going to find out. Now we already got all the information related to the you can say block. Now we are going to shift our analysis to the projectile motion. Okay. So let us start by pebble projectile motion. Pebble projectile motion. So it is given that at, you can say, after t is equal to 1 second, the pebble is going to hit this block. Okay, so it means the position of this will be the position of the block, and it will be distance of 5 meters from point O, and this is a pebble. The total distance between the point O and point P is given as 10 meters. So which means the pebble has to travel a distance of 5 meters within 1 second. Okay. So this is the v velocity, and it is at an angle of 45 degrees. So the distance which the pebble has to travel within 1 second is our 5 meters. So we can say for pebble to hit the block, the horizontal distance to be traveled by it in 1 second will be equal to total distance, that is 10 minus 5. This will be equal to 5 meters. Okay, so the distance the pebble has to travel so that it is able to hit the block will be only 5 meters, and it has to be covered by in 1 second. And we are given that the velocity of the pebble is at an angle of 45 degrees with the horizontal. Okay. So this is our horizontal, and we have a velocity v. So we can divide at an angle of 45 degrees. This is point P. So we can call this as v of x, and we can call this as v of y. So we can say the horizontal velocity is our v of x, and that will be equal to v cos of 45, and this will be giving us v square root of 2. And we can find out the vertical velocity v of y, which will be equal to sine of 45, and that will be also equal to v square root of 2. And if t is the time taken by the pebble to cover the 5-meter distance, so you can say that the horizontal distance in time t, horizontal distance covered by pebble in time t, this will be equal to horizontal velocity multiplied by time t, and that is equal to our Vx is our v upon square root of 2 multiplied by time t. Okay. So therefore, and let us call this as HP, horizontal distance of pebble. Okay. And let this call as this distance as HD. Okay. So we can say that at time t is equal to 1 second, HD should be equal to HP. At time t is equal to 1 second, HP should be equal to HD for pebble to hit the block. So we substitute the value, we get this as 5 will be equal to v upon square root of 2 multiplied by this, you can see 1. So from here we get v, that is 5 square root of 2. Okay. And the options that are given to us is in terms of everything square root, so we can modify it. So we can write that v will be equal to square root of 5 square multiplied by 2, and this gives a square root of 50 meter per second. So this is the value of pebble velocity v. Okay, so you can say v is equal to square root of 50 meter per second. This is the pebble velocity v, and the options that are available to us, we can see that option number A is the correct option. So we can say that option A is correct. And we can also verify the answer. Okay, let us try that also. Verifying, and the verification is with respect to the vertical motion. Okay. If the vertical distance traveled by the pebble after the solution comes equal to 0, so it means the pebble is able to hit the block. So let us verifying the vertical motion. So you can say that when pebble hits the block, vertical distance vertical displacement rather must be zero, and this happens at t is equal to 1 second. At t is equal to 1 second, so we can write the formula that the vertical displacement for projectile motion, vertical displacement for projectile motion we can say that, let us call that as y. Y will be equal to v of phi t minus half g t square. V of phi is our v upon square root of 2, and we found out that is square root of 2 multiplied by 1 minus half into 10 into 1 square, and v is our 5 square root of 2. So we can say y is equal to 5 square root of 2 square root 2, and this goes by 5 minus of 5. So square root and square root cancels out, and we get this as 5 minus 5, and which also cancels out. So we get this is equal to 0. So y is equal to 0. So vertical displacement after t is equal to 1 second is equal to 0. So this makes sure that our calculation or answer is correct. So this completes the question. Thank you.